In 1961, India became the first Asian country to make an indigenous fighter jet by launching HAL Marut. It was an incredible achievement for a poor country that had just gained independence. So how did India achieve this remarkable feat? This video was made after a month of intense research, 2 RTI filings, 3 weeks of 3D modeling, and a month of editing. We also enhanced low-quality black and white photos using advanced neural networks to never-before-seen quality levels. By the end of this story, we will learn how the geopolitics of 12 countries spread across 5 continents influenced the creation of this aircraft. The story of Marut starts in Germany with a talented Nazi engineer named Kurt Tank, who had designed the Focke-Wulf 190, which was a legendary fighter aircraft of its time. It was so good that it was the backbone of the German Air Force, with over 20,000 units manufactured. He had also designed the Focke-Wulf 200 Condor passenger plane, which was also used by Hitler as his personal aircraft. After the fall of Nazi Germany, the now victorious Allied countries started poaching the brilliant scientists and engineers behind the ingenious Nazi innovations to make them work at their own research facilities. Declassified documents show that under Operation Paperclip and Operation Osowiecim, thousands of specialists were forcefully recruited by the United States, Soviet Union, and Britain. Most of them were abducted at gunpoint along with their families, and later recruited to work in research facilities to make rockets, planes, and weaponry. There were also special operations to kidnap experts who were likely to migrate to Spain, Argentina, and Egypt, as these countries were considered Nazi sympathizers. While Kurt Tank was under house arrest, he managed to flee to Argentina in disguise, with a forged passport given by Argentinian spies. Later, 60 of his former colleagues also followed him, and Argentinian President Juan Perón recruited them to make their first fighter jet. He designed a state-of-the-art aircraft, but while it was in the final stages of completion in 1955, the Argentinian president fell out of power due to a military coup, and the new dictator started harassing Kurt Tank by arresting him for possessing a forged passport. Thus, he had to flee again. To continue his dream of making a supersonic aircraft, he offered to develop a fighter jet for India, which was promptly accepted by HAL. And thus, Kurt Tank, along with 17 colleagues, moved to India while a majority of his team migrated to the United States. But due to the delay in getting the funds from the government, he started working as the director of the prestigious Madras Institute of Technology. Coincidentally, one of his promising students at that time was APJ Abdul Kalam, who would later design several important rockets for India and go on to become the president. The Marut project was approved the next year, in 1956, with Prime Minister Nehru giving a speech in Parliament that was highly supportive of indigenous manufacturing of fighter jets. At that time, India had a small aviation industry that maintained and overhauled Allied warplanes during the Second World War. After the war, this facility near Bangalore was renamed Hindustan Aeronautics Limited and license-produced the de Havilland Vampire aircraft. What HAL lacked were aviation designers and testing infrastructure, as HT-2 Trainer was the only aircraft it had designed to date. Even so, the Air Force gave a tough requirement that called for a multi-role fighter capable of operating both as a high-altitude interceptor and as a low-altitude ground attack aircraft, with a speed of Mach 2, a flight ceiling of 60,000 feet, and an 800-kilometer radius of action. Also, the plane was expected to be adaptable as an all-weather interceptor, as an advanced trainer, and as a naval fighter for use aboard the aircraft carrier Vikrant. This was an impossibly high requirement for even the most developed countries of that time, considering that the first production plane to cross Mach 1 was introduced just 5 months earlier, and there were no Mach 2 capable production aircraft anywhere in the world. The requirements were set clearly with the future in mind, as 4 years later, America's Starfighter became the first to cross Mach 2, while the Soviets crossed it a year later with their MiG-21. With such ambitious requirements, the project began in 1956 with Kurt Tank moving to Bangalore along with 17 colleagues. Upon arrival, Tank found that HAL neither had the required personnel nor the infrastructure to take upon such a complex project. HAL's entire design department only had 54 members. Worse yet, no hangar space was available for the construction of prototypes. No machine shop existed for prototype engineering, and there were no test equipment, structural test rigs, or even a runway from which the new aircraft could be flight tested. Tank quickly realized that he had to not only design an advanced supersonic fighter jet from the ground up, but had to also help establish a contemporary industrial complex capable of developing one. In the very first week, a qualified production engineer and his team resigned after concluding that it was not a place capable of developing an aircraft. 3 more of his colleagues resigned over the next few months. Even after facing such a huge challenge, Kurt Tank persisted, and under his leadership, HAL's design department grew 12-fold, and its facilities and infrastructure were expanded massively to accommodate a project of this scale. The first year was spent in building the entire infrastructure from scratch. Work on the fighter jet began in 1957, and it was given the name Marut, which translates to the Spirit of the Wind. Within 2 years, they had already produced a full-scale glider mock-up made of wood, which was then towed in the air by a Dakota aircraft to test the aerodynamics. Marut was the last plane in the world to be flight tested this way. Assembly of the first Marut began in 1960, and it was flown for the first time in 1961 by Wing Commander Surenjan Das. After extensive structural tests, the final version of the plane was ready by 1962. At that time, it looked like a plane ahead of its time, with a state-of-the-art aerodynamic design, high maneuverability, and excellent safety features, like the way the failure of one engine did not damage the other. Its armament consisted of 4 30mm Arden cannons that could fire 1,400 rounds per minute, 50 Matra-type unguided rockets, 4 underwing hardpoints that could carry extra fuel tanks or air-to-ground rockets, or up to 1,800 kilograms of bombs. Overall, it was a great package, as Marut was aggressively priced at 66 lakh rupees, which was a great price even for that time. But there was one big problem. This supersonic plane designed to fly at a speed of Mach 2 was not even able to cross Mach 1. The problem was not with the plane, but with the engines. The Marut was planned to be powered by a pair of British-designed Bristol Siddeley Orpheus 12 afterburning engines, which was under development at that time for Nat Mark II and a NATO light fighter. So, Marut was temporarily using an older Orpheus 703 non-afterburning engine that produced 44% less power. In an unfortunate turn of events, NATO cancelled the aircraft for which this engine was being developed, and thus they pulled the funding for this engine. The manufacturer asked India to underwrite the engine development costs of £1.5 million, which the Indian government refused, and hence, this engine was never developed, leaving the Marut without the engines it was designed around. £1.5 million, or 2 crore rupees, was not a large sum by even the standards of the 1960s, but it may have looked like an outrageous amount when compared with the cost of development of the entire aircraft, which to that point was just 4 crores. This short-sighted decision wrecked the entire project, as it initiated a lengthy and frustrating search for an alternative engine. The Soviets offered the RD-9 engine, which was found to be technically suiting but required extensive modification, and Soviet engineers refused to guarantee anything more than a speed of Mach 1.4, while India insisted that it needed Mach 2, as Pakistan had just received Lockheed Starfighter from the US, which had a speed of Mach 2. Pakistan had got this plane because an American spy plane based out of Peshawar was shot down over the Soviet Union, and they had threatened to attack Pakistan. Spooked by this, Pakistan approached America for better warplanes, and they got a squadron of starfighters, which was considered the best fighter of that time. Later, France offered its ATAR-9 turbojet engine, which was used in the likes of the Dassault Mirage and Super Étendard, and had 60% more power than Marut needed, but India reportedly showed no interest. At that time, Egypt was also trying to build a similar supersonic fighter led by another legendary Nazi aircraft designer, Willy Messerschmitt, who had designed the world's first operational jet fighter, the Me-262, and the infamous Bf-109, which is the most produced fighter in history. He had escaped to Spain after the war, where he had started making a fighter jet for them, but due to spiraling costs and cheaper American alternatives, Spain cancelled the project. Egypt, which was eager to build its own fighter jet out of the fear of sanctions, saw this as an opportunity and acquired the entire project along with the equipment and employees from Spain. They were also temporarily using the same Orpheus 703 engine, but Egypt had decided to build their own engine from scratch and had recruited Ferdinand Brandner, who was a legendary engine designer of Nazi Germany. After the war, while trying to flee to Prague, he was captured by the Soviets, and then he worked in the Soviet Union for a few years building engines for them, including the most powerful turboprop engine in the world, until he escaped to Austria. By 1965, Egypt was spending more money on designing this aircraft using foreign talent than their total investment in its entire civilian industry. And when Brandner learned India was also building a similar plane, he came to India, met Tank, and negotiated a deal under which India would share the engine development cost and also provide 2 test pilots. This was because Egypt did not have any capable test pilots, and they were unable to hire anyone from elsewhere. In 1966, a Marut was taken to Egypt along with a 30-member HAL team. They fitted it with their engine and conducted nearly 100 test flights, but at that time tensions were rising between Israel and its neighboring Arabian countries after Egyptian president in an act of war blocked Israel's access to the Red Sea and mobilized their army. Spooked by this, Israel launched a preemptive strike in which 90% of Egyptian aircraft were bombed while on the ground, including a plane used for testing the engines. After that, Israel captured large swaths of land and then forced for a peace agreement. The Indian team came close to being hit and had to return immediately, leaving Marut behind. In the aftermath of the war, Egypt needed a new air force fast and could not afford to pour more money into a long, drawn-out fighter jet program, and thus the project was cancelled, and they immediately purchased MiG-21s from the Soviets. The Indian government made no attempts to either acquire the engine or the engine development team, thus losing the entire investment. In 1962, Chinese President Mao Zedong was facing a huge public protest over his poor agricultural policies that resulted in the largest famine in human history, which killed over 50 million people. To create a huge distraction and to unite the public against a common external enemy, he started a war with India, which had had a very friendly relationship with China at the time. This surprise war shook India to the core, and due to the urgent need to beef up the Air Force, India bought MiG-21 Interceptor and Sukhoi-7 ground attack aircraft from the Soviets in the thousands. Both of them were Mach 2 capable and competed in the same roles as Marut, thus killing the need for this project. Without being able to find a suitable engine and without much political interest, many of the intended features of Marut were cancelled, and it was handed over to the Air Force in 1967, while still being fitted with its temporary engine. The Air Force reluctantly purchased 147 Maruts, as they considered it to be only marginally superior to their existing fleet of Hunter aircraft. Kurt Tank left HAL the same year and returned to Germany. In the 1971 Bangladesh Liberation War, the Marut remained in the thick of the action, strafing airfields, bombing ammunition dumps, and hitting tanks and artillery on the front lines, cementing its position as a capable ground attack aircraft. Several Maruts managed to return to base on just one engine after the other was shot up. The jet's flight controls were designed to revert to manual control automatically if the hydraulic system failed, and many flew home safely after the hydraulics were shot out. Major Bakshi of 220 Squadron even scored an air-to-air kill of a much superior Pakistani F-86 Sabre. No Marut was lost in air-to-air combat, but 3 were lost to enemy ground fire. The Marut proved its mettle by playing a key role in the legendary Battle of Longiwala, in which a brigade of 3,000 Pakistani soldiers accompanied by 40 tanks attacked India at midnight, intending to capture large swaths of territory. However, they were stopped by a small border post guarded by just 120 Indian soldiers, who had just one jeep-mounted recoilless gun and 10 camels. At that time, the Indian Air Force did not have night flying capability, so these soldiers had to hold their position till morning, and to everyone's surprise, they were able to not only defend themselves, but destroy 12 tanks with their jeep-mounted recoilless gun, and also cause huge Pakistani casualties. At sunrise, a squadron of Maruts accompanied by 4 Hawker Hunter aircraft started raining fire upon the Pakistani formation. Without effective air support from the Pakistani Air Force, the tanks and armoured vehicles were sitting ducks to the Maruts, and many attempted to run back to Pakistan. India did not push home the advantage and allowed them to flee. At the end of the battle, Pakistan lost more than 200 soldiers, 36 tanks, and over 100 vehicles, while India lost just 2 soldiers, 1 jeep, and 5 camels. This outcome is particularly remarkable as Indian aircraft did not have guided anti-tank missiles that give modern ground attack planes high lethality. At the end of the war, 93,000 Pakistani soldiers surrendered, and a new country, Bangladesh, was born. There were several proposals to make a second version of Marut with better engines and features. Even Kurt Tank had proposed an aircraft called HF-73 with the British Rolls-Royce RB199 engines, which were 3 times as powerful as the current engine. But later, access to this engine was denied due to concerns that India may end up building a better aircraft than the Western alternatives. By then, everyone had realized that it was more profitable to sell India fighter jets rather than selling just the engines and enabling India to become a future competitor. India had set up its own engine research organization called GTRE in 1959, which tried several times to modify the existing engines to gain more power. In 1970, while testing a reheated version of the engine which had 25% more power, India's foremost test pilot, Group Captain Suranjan Das, met with a fatal accident when his canopy malfunctioned. Although the accident was not caused by the improved engine, this incident caused the cancellation of any further engine development. The Marut did not have advanced sighting systems or cutting-edge navigation systems or powerful engines, but it did get the job done in the ground attack role. Moreover, being an indigenous design, it presented scope for further growth with no intellectual property rights or technical roadblocks. Despite its inherent potential to form the foundation of a robust indigenous aircraft industry, Marut was withdrawn from service in 1982, and no further versions were made. The Air Force instead went on to buy the British-built Jaguar and Soviet-built MiG-23. By the time India decided to make Tejas, the second fighter jet in the late 1980s, the skills and experience gained from this project were lost due to the lack of continuity, and they had to start from scratch again. It would not be unfair to say that, for want of an engine, an industry was lost. The Air Force was not unhappy with this situation as they were able to purchase ready-made aircraft from experienced foreign companies. Put plainly, they were not confident of HAL's ability to design and develop advanced aircraft required by them. HAL was not unhappy either, as they were having enough business through production under license. The bureaucrats were not unhappy either, as they did not have to answer any embarrassing questions from the parliament. And the government was not unhappy either, as they did not have to deal with the delays and problems associated with such complicated projects. Marut had a great design and proved to be the safest plane India had at that time. This project was also the first attempt of its kind anywhere outside the major powers, and unlike the fighter jet programs of Argentina, Spain, and Egypt, the Marut entered production and fought well in a war with good serviceability records. And overall, it had cost just 21 crore rupees for the entire project, including testing of various engines over 19 years. But unfortunately, the Marut project was hampered by overambitious goals, poor government oversight, and underpowered engines, producing a subsonic light attack plane, foreshadowing some of the difficulties that would plague India's second fighter jet, Tejas, which has been under development for over 40 years.